Hello everyone, welcome back. This is a new lecture in your course Mastering Docker. My name is Ahmed for Avionics, and in this section we are discussing Docker containers. In the previous lecture we have stopped at how Docker deals with container IDs and how you can interact with containers using either their full container ID, their shortened container ID, or their names. And speaking of names, Docker has a mechanism of automatically assigning human-friendly names to containers that the user did not assign names for. Naturally, container IDs are hard to remember and are so hard to read, also having to manually issue a new name for each container may be a headache. Consequently, Docker uses a naming convention to assign names to new containers. This naming convention consists of an adjective, followed by an underscore, followed by the last name of a famous scientist or an engineer. So to see that in action, just let's clear that screen. Let's have a look at Docker PS. We have already created all the containers that we have created, we have assigned names for. Now let's create a container that does not have a name. Docker run, and I'm going to use BusyBox again. It's just a tiny image used for tests. And I'm going to run just sleep. And don't forget to run -d to be running in the background. Let's run 3 or 4 of these containers. Let's clear the screen, and now if I have a look at Docker PS, I'm gonna see that Docker has automatically assigned human-friendly names to those containers. And as you can see here, the naming convention consists of an adjective, jovial. Here in this case, this example is jovial, followed by an underscore, followed by the last name of a famous scientist or engineer, just famous person. Here it's Gates. Of course, it's the last name of the famous Bill Gates. We also have here the second container. It has tiny underscore Poincare. I hope I'm pronouncing it right. We have here agitated, Euclid, romantic Poincare, and so on. So this is just a name that Docker provides to the container. This is a human-friendly name, and this is just because the container must have a container ID and it must contain a name, or it must have a name. So if you do not assign a name to the container, Docker will automatically assign a name for you. So as we have mentioned in the previous lecture, it is a very good practice to establish your own naming convention, your own naming pattern for your containers in order not to lose your way trying to figure out which container dealt with which environment or which command, instead of just resorting to Docker assigning those to your containers. Now, let's have a look at another topic in this section, which is creating neutral systems. And by a neutral system, I mean a system that is not dependent on the environment on which it is running. In other words, I want to create an environment-agnostic system. Now, more often than not, when you create, for example, a web application, you are depending on some of the environment variables, like, for example, the database name, or the location of a file on the file system, or the value of a certain environment variable, and so on. When you move this application, this web application to another server, let's say the production server or even another testing server, you find that you have some problems starting the web application, just to discover that you have forgotten on some environment variables on your host operating system or host system. Those environment variables need to be reset again on the receiving system, on the target system, so that the application can run correctly. We need to minimize this practice as much as possible, or at best we need to eliminate completely any dependence on the hosting environment. We need to create a system that can be easily portable from one system to another, just to take the system from your development machine, put it on a production machine, or put it on another test machine, and it should work the same way it works on your machine. And this is the whole point of using Docker. And Docker provides for this approach, it provides 3 methods, which are read-only file systems, environment variable injection, and volumes. And volumes will be discussed in detail in a later section in this course. So let's have a look now at read-only file systems and environment variable injection. Now, a read-only file system, as the name suggests, is a file system that denies any reads or changes to it. If you create a container in a read-only file system, this means that the system cannot make any changes to that file system as long as it is running. It is just used for reading. You cannot make any changes, you cannot add any files, you cannot delete any files, you cannot change the contents or even rename any file on that file system as long as it is read-only. This is helpful when dealing with applications that uses databases massively to store and manage their data. A very famous example for those types of applications is content management systems, or CMSs for short. I'm talking about WordPress or Joomla or Drupal or other famous content management systems. Those systems are web-based and they use the database that is often MySQL to store all the data that they deal with, including their own configuration data. It also helps provide a level of protection to the container. If it gets compromised, the attacker will not have a chance to do any damage. Now imagine that you have a container that is running in the background and hosting a web application, and this container is preventing any access or any changes to its underlying file system. Of course, this provides a strong level of protection in the sense that if the system was compromised for any reason, the hacker or the attacker that was able to break into the system will not be able to make any changes to the file system. He will not be able to delete or change any files because the system was designed to be just read-only. If you want to specify that a container will work in a read-only mode, you have to use the --read-only flag with the name. So let's have an example or a small lab in which we are going to use one of the CMS systems that we have just mentioned, which is WordPress. We are going to create a container based on the WordPress image. Docker Hub, luckily enough, has a ready-made WordPress image. We are going to use this image and build upon it a container that is going to be using a read-only file system. So let's have a look. So it's Docker run. Okay, of course it's -d to run in the background. --read only. Let's use the name of wpress to be somewhat descriptive. Okay, so --name wordpress and wpress, and we're gonna base this on WordPress. And optionally, you can add a column to the image, and you can enter the version of that image. So, for example, the latest version of WordPress, as we are currently recording this video, is 4. But you can use other older versions of WordPress if you want to, as long as Docker Hub has that image available. Okay, but here we are interested in the latest, and because of that, we can completely omit this column, which will by default include the latest version of WordPress. Let's press enter, and of course as I have mentioned earlier in this section, I have already downloaded the images that we are going to use in the labs of this section. Because of that, there was no image pulled from the Docker Hub. If you want to make sure, let's have a look at Docker images. As you can see here, I have those images already installed in the system, because as you can see, it is a relatively large in size, so I have opted to download them before the start of the lab just to save time. Okay, so back to our topic. Now we have a read-only file system running an instance of WordPress in a container called wpress. Now everything should be running correctly, right? Let's have a look at Docker ps. And guess what? We have no WordPress container running. WordPress container has failed to start. So let's have a look at why this happened. We have already learned that we can use Docker logs to display the status or display the image or display the messages that the container has output to the screen or to the standard output. So Docker logs and the name of the container was wpress. Okay, let's have a look here. We have some missing environment variables. WordPress DB password environment variables missing, and that further implies that we need a database to be installed in another container in order for WordPress to use it to be able to work or function properly. And we are gonna do just that in the next lecture, so stay tuned.